Good evening, everybody. Welcome to our March 2022 meetup. We're going to be doing some lightning talks by speakers within the Java community. Just as a reminder, we are on Slack. If you go to chicagotechslack.com, I believe we're in the Java channel, and there's other tech available within that Slack if there are other things of interest to you. It's a good place to find anything and everything related to Chicago Tech. We have Java Offheap, which is a great podcast source for current Java news. Also, we're on meetup.com, which I'm presuming most of you probably came here because you found us on Meetup already, but in case any of you didn't see us on Meetup, we are on Meetup. We are also on Twitter. You can follow us at CJUG. We also have a chat channel on Discord. This gives us the ability to engage with speakers before and after meetups. This is also an additional way to just communicate with each other. Something I really appreciate about Discord is that, unlike Slack, the messages don't delete after a few months or after so many messages. So this is the link if any of you are interested in joining. Excuse me. Also, some other community info. We have an ongoing virtual jug in the North America. It's called vjug.us. Also, there's a website, devitjobs.us. And we are a community partner of these groups. All right, we've got some upcoming meetups and events in March and April. March 10th, we have integration testing with test containers with Cora and Maria from the VMware Spring team. And then we also have on March 24th to Java 18 and beyond with Billy from Oracle. To be determined, we've got an April topic by Gautam, who's a longtime CJUG member and supporter. We also have the Spring One tour by the Spring team in Chicago. I've been to Spring One before. I recommend it if you can go. And a full-length Meetup at a future meetup near us. If you're interested in speaking, please feel free to submit your proposals to present at cjug.org. We also have a jobs board on LinkedIn if you join the CJUG group. Also, our gold level sponsor is JFrog. So thank you, JFrog, for supporting us. I don't believe that anybody from JFrog is here tonight. However, if you all stick around till after the talk tonight, there will be an IntelliJ raffle. All right, our speakers from the community. Nilesh Patak, whose topic will be functional programming in Java, and Anna Marsh, software engineer at Microsoft, with the topic building bytecode the hard way. All right, well, looking forward to hearing from both of you.
Thank you, Josh. Yep. So welcome speakers Nilesh and Anna. I guess the order doesn't matter if you agree one go before or first or second or whoever. You can also decide between yourselves. I just happen to
I can go first.
You want to go first? Okay. Yeah.
Okay. So functional programming. So I'm Nilesh Pathak, and I'm a senior software developer working in Chicago in a bank. I'm a senior Java developer. What it means is that most of the development I have done, at least until recently, is using object-oriented programming. But at some point of time, recently, I got introduced to functional programming, specifically after getting features in Java 8. I don't know how I got introduced. Maybe I talked to a Scala developer or something, not sure. the point I wanted to make is that once I started using it, I kind of started liking it. Like I'm a OO guy, but I started liking functional programming, and I started using it more and more. And now any new application I start, I don't start it without thinking about functions. So just a question, like, has anybody, like whoever is a Java developer, have started using functions in the group?
A little bit.
A little bit, yeah, okay. Yeah, we are also Spark shops, like big data. So I heard that functions are, kind of a big part of doing those kind of software development. It helps. So I kind of try to adopt it. Anyway, so topics that I wanted to cover today are, sorry guys, I'm getting used to this a little bit. Our introduction, features, some Java API features that are available to develop functions. Advanced features like currying, design patterns, which involves functional programming, etc., and some examples.
Mm-hmm. And Nilesh, excuse me, Nilesh, would you like to run this as a slideshow? That way, it takes.
Sure. It's like this. Okay. All right.
Yeah, you should be able to.
Okay. Oh, can everybody see it all right?
Yep.
And then I can move like page up, page down. Okay, good.
Yeah, that's right. That's right. Yeah.
Okay. So introduction. Functions, if you talk in mathematical terms, are nothing but you give them a set of input and you are expecting a specific set of output. That's what it is. And that idea is taken from mathematics to have a functional programming style. A functional code is a computation done evaluating set of functions. So that's how you develop a use case in a functional programming, as opposed to object-oriented, where you start thinking about classes and relationships. You will start thinking about developing functions, and then later on combine them in various ways, chain them, and then create a use case. The output of a function only depends on the input to value. So this is a very important point, and this is one of the reasons to move sometimes to functional programming, is that you are able to develop a code which has a less chance of having bugs, because there are very few side effects. You're trying not to, and now Java doesn't support all these things, but you can discipline yourself. So you're not trying to mutate a state. Okay, you try to develop your functions. That means you don't change the value of a variable, and you don't do other stuff in a function that can create bugs. The types are not the classes. So that is another important point. A function, right, is defined by what you give it and what you get out. What it means is that if you have interface, right, which has a different name, two different names, but if it is doing exactly the same thing in terms of input and output, so it takes the same type in, gets the same type out, the implementation is kind of interchangeable. So that's important to understand over there, that what is a type in a function. Functions are first-class citizens in functional programming languages. What it means is that you can assign them, you can pass them as a parameter to a method, you can return them, and you can compose a bunch of other functions by combining existing functions. I gave a simple example here. There is a mathematical notation that function is like if you have a function of x, and if it is adding x plus 1, how you represent it in Java. So Java has an interface called functions. So if you say function of integer, that means that it is taking an integer and it is returning an integer. And the implementation is another interesting part that Java 8 has, is a Lambda. So it makes functional programming easier. Lambda is an implementation of a functional interface. And this notation tells you that it takes x and returns x plus 1. Features. Let's talk about some features of functional programming. It is declarative versus imperative, means your client code looks like it is telling you what it is doing, like a story, and the implementation is kind of hidden from us and makes a fluent, easy to read client code. That's the idea. Immutability versus mutability. What it means is that you are not messing with state. And what that helps with is that you can you can execute your code much more easily in a concurrent fashion. So you can make it concurrent much more easily without worrying about bugs. Expressive client code, which I like the most about functional programming, is that once you adopt this, you are able to write a code which is telling you what it is doing and makes it look clean. Dry means it's easy to not repeat yourself. So when you're developing a function, then you specifically know that what kind of API you already have, what kind of logic you already have somewhere, because you develop a small, concise function for it. And so now a situation comes when you are actually need to use that same logic somewhere else. I find it much more easier to do it when you are developing functions. Testing is also easier because, as I told you, there are less side effects. That means you are able to test your code by testing a bunch of functions, as it depends only on the input that you're providing and nothing else. Less boilerplate code. So you don't have to develop all these classes all the time, right? So that's once you develop functional programming, you are just providing implementation that single function interface that you have. There you are just keep providing implementation of that or any other single interface, single method interface develop. You just keep providing implementation, and implementation is also much more easier with introduction of Lambda expression in Java 8. No side effects. That's another. I'm repeating myself, but here I'm specifying that no side effects means you should not be trying to make DB calls in your functions, and you should have specific, like you should do it as at the end of your execution of functions. So should keep it pure, not mutating variables, and keep them pure, testable, reusable functions. And what that leads to is something called referential transparency. What it means is that if you have expression, right, if you implementation of a function, and it is giving you some results, would it be same if you replace that whole expression with that returned results? Would it be same? Now that won't be true if you are making DB calls or mutating some variables or even doing some loggings. That won't be true, right? It will be different. So that's what it leads to, referential transparency, that if you develop your functions, you can replace it with its value and still the result will be the same instead of expression. Now, that leads to one other more subtle thing, which we don't get too much into usually, is the compiler optimization. So if compiler finds that certain expressions can be replaced with just pure simple value, then it will do that. So if certain part of code can be optimized by compiler, if you adhere to this stance. Now let's look at some Java, what it provides in terms of functional programming, what kind of API it provides. So there's a package, java.util.function. It has a bunch of stuff in it. I did not list more. I just listed a few important ones which we more normally or more frequently use, commonly use. So first is function tr. What it means is it takes the value of type t, returns r. Supplier, which takes nothing, but returns the value of type r. Consumer takes type t, but returns nothing. And predicate takes a value of type t and always returns a Boolean. So these are the interfaces, and then you have to implement them to develop functions. There is one more thing at the rate functional interfaces, annotation. It helps you define interface with a single method, because that's what you need to develop functions. So it helps you make sure that your interface does not go aboard more than one method. And that brings to next point is any interface in Java. If it is a single method, right? Any old, like if you develop in Java 7, that's fine. Any interface which is a single method, you can use it you can implement it using Lambda, and then it becomes a function for you. And functional programming very extensively uses the feature of we able to provide methods in interface call default methods, right? So a lot of design patterns and functional programming, like chaining or partial application of the functions, it kind of uses this default method tricks with the default. So that's how Java has provided functional programming: use single method interfaces and this default methods, and Lambda together works to give us a feel of functional programming. Function composition. So combine two or more functions to create another function. I mentioned this point before. This is an example. So for example, function one is add one, which is very simple. It takes an integer, adds one to it. Your second function is mult2. Very simple, takes an integer, multiplies it by 2. Now, suppose if you need a use case where you want to add 1 and multiply 2, then you can do this. You can create a third function, naming it, say, add 1 mult by 2. And how you define it? You take add 1, and then you call the and then, which is a default method of a function interface. And then you pass the second function mult2. This will give you a third function. And now what the third function does, every time you give an argument to it, right, the way it is shown below, say, for example, I gave 3. So it will first add 1 to it, and then multiply it by 2, and thus the result 8. Same thing you can do using another default method compass, just the order is reversed. Like the function on which you call the method and the function that you pass gets reversed because the sequence is reversed in that, but does the same thing. And Lambda. So it's really, really cool thing in Java 8. And now, I mean, more and more we should use it, is this Lambda expression. And significance of it is shown here in this example, where before Lambda, we used to do anonymous classes, and then you see how you have to like 4 or 5 cumbersome lines to provide comparator, which will short your collection, right? So this is how we used to do it. So that is replaced after introduction of Lambda in Lambda notation. If you see below that in collections, you pass with your collection starts short. With your collection, you're going to pass a simple Lambda expression, which tells you, which is going to instantiate your anonymous class using Lambda, right? So this is the same thing, but you are just writing this Lambda expression, which is n1, n2. So it takes two objects and compare them, do a natural comparison. Method reference, which is, again, one of those way to express Lambda that is provided in Java is, if you are writing Lambda, say, for example, takes a string and converts it to uppercase and returns it, that whole Lambda, if you like it, you can write it this way: string, colon to uppercase. And if you think that is more readable for you, there is another way of method references, another way of writing Lambdas. A lot of IDEs nowadays just converts it for you, if whichever way you like, back and forth. So Java just has, so this is the thing about Java, though it's not a functional programming language. There is no language support. There are some bunch of interfaces that you have to use, and that's why sometimes it makes it hard to implement functional programming in Java. So you can go to the extent that you can, and then you can stop there, it looks like. But other programming languages are way better in terms of functional programming languages are way better. Haskell or Scala in supporting features of functional programming. So let's go through some of the advanced features which comes from the things that I have started. Once I started using it, I learned about them and I started implementing those in my code. Parameterized function. So what is it, right? So you have a function and its action, you define a function, but you can actually make its action depend on how you parameterize it. So the action of a parameterized function depends on external constants. You can make it depend on an external constant that you pass to it. So if you have one function, by passing a set of constants, you can have 100 functions. This is known to be useful in like machine language kind of code, where you have millions of data points, but same operation to do, and you can create thousands of functions from a single one by parameterizing them. This can be implemented using, so the way to implement is use something called higher order function, which are nothing but the function that returns function. We use this to create multiple instances of a function based on set of values. So those are the values that you pass. They become closer in your function logic, and then gives you a new function. So here is the example, right? I named it a higher order function, which is taking some constant, and it is returning me another function. Why do I know it is returning a function? Because of the lambda expression. As soon as you have a lambda expression, that's a function. And you can see the function definition itself, which says it takes integer, and then it is returning this function, right? So it is returning a function. So it takes an integer and enters another function, okay? Now, how you can use it? So this implementation just adds integer to a constant. Whatever integer you pass, it will add to this constant, right? So I can create two functions out of this. One is my add1, and another is my add2. See how when I apply the argument to higher order function, it gives me another function. When I apply argument 1, it gives me an instance of another function. When I apply argument 2, it's giving me another instance of a function. So I have two functions now, add1, add2. So now I can directly use those, add1, add2 to any argument. And here I have shown that when I'm passing 1 to both of them, they give me different results because one is add1, one is add2, and that's how I have parameterized them. Currying. Okay, yeah, this another, currying is another feature of a functional programming that I'm using. So what it is that if you have a method, like a static method or a function, you can call it, which has a multiple parameters, you implement that method in functional programming by developing a sequence of functions that each takes a single argument. It is recommended that even though Java has something called bifunction, I think in functional programming, it is recommended that you develop a single argument functions and then you combine them to reach your end goal. So try to develop a function which just takes single argument, and this helps to follow that. This is like more scientific mathematical definition of currying is that the procedure of viewing a multi-arity means argument operation as a sequence of abstractions. You develop multiple interfaces, sequence of interfaces that yield an equivalent unary operation. So like in your client code, it will look like a single operation to you, and that is currying. Okay. So as an example, I have given here a static method, which I called it map data. It is supposed to apply some kind of mapping logic between the two classes. And once you give object of class source, it is by applying that some mapping logic, it is supposed to give you the target object, destination object of type D, right? So now this is a 3-argument method class of source, class of destinations, and object, source object, right? How do you convert them into functions, set of functions which only takes one argument? So a way to do it is define like a set of interfaces / functions in such a way that they are related. How they are related? So for example, your first interface will take an argument, which will be your first argument of those 3. And it will return you another function, right? So now that gives you, when you return a function, that gives you the opportunity to find another argument, because what function does, right? Function takes an argument. So your first interface / function takes an argument, which is our first argument, returns a function. What does that return function do? The return function takes your second argument. And then if that is not end of it, if there is a third argument, you can return another function, right? And then that function, in my case, is I'm done with the arguments. I got all my 3 done, right? So now all I need is, now I'm ready for my actual implementation. So I used this single argument 3 functions, chain them by having one return the other. And The final one, what it is doing is giving me what I want, which is my destination object of type destination, right? It takes a source. So this is how it is chained. If you look at the code, one returns another like that. Now, this is just the function definition so far, right? Using default, as I told you, it uses default method and single method interfaces to implement functional programming. So now this is the definition of the function. How do I implement it, right? So here I have shown the implementation. So I've created a method called mapFactory function implementation, and the return type of that is my function that I want to implement, which is mapFactory function. That is what I want to implement. And look at the implementation, how simple it is. It is telling you that in a Lambda expression that it is taking a source class, then it is taking a destination class, then it is taking a source object, and after that, you can write some API specific logic, which will use these three to give you the target object. And look how your client code looks. And that's what I mostly like about functional programming is this is how your target code looks, that I'm trying to get a destination object, right? So I have a function that I'm accessing using parent class, and then I'm specifying the type, source type, destination type, using generics. Generics is very useful in functional programming. Mapfactory function implement is my function. I'm parameterizing using source type, destination type. So now this is very reusable. I can use it for any other two types. And then how am I passing my argument? Instead of 3 in a method, it's more readable now, right? Each argument, I have a name for it, and I can choose my names the way I think is more readable. Here, they are very simply specified. It says source class, and then I pass the source class, and then destination class, I pass the destination class, and then destination object, right? So how clean the client code looks because we used, I think I am at partial application. I am not able to see the whole thing. Yes, I am at partial application. Yes, partial application. So what is partial application? So create another function from a multiple argument function by fixing the value of one of its arguments. So another feature of a functional programming that is useful is that when you have a function, but if you know that for a bunch of values, so for example, a function with the 2 arguments, and out of those 2 arguments, you know that the one argument is going to be same for a bunch of values of the second argument, right? So here is the scenario. You want to calculate a weight, and you implement it like, I'm going to give mass, I'm gravity value, and then mass times gravity is how I'm going to calculate the weight. But gravity is going to stay same wherever you go on Earth. It's going to same wherever you go on Mars, right? But those 2 values are different between Earth and Mars. So what you want to do is you can use the same function and create 2 other functions by partially applying gravity, right? So even in the first case, you apply the gravity 9.81, and that is your function for Earth. You apply 3.75. There is a function for Mars. And now everywhere on Earth, you can use this function. Everywhere on Mars, you use this function. So you same weight, same 60 mass will give you different values when you apply appropriate function. Combinator design part. So this is something, now more specifics into various tricks you can do with functional programming. This is more, it's a design pattern specific to looks like functional programming. By the way, a lot of other design pattern and software development principles can be developed using functions too. I mean, we are not letting go of those things just by using function, right? You're already implementing 2 of the solid principles, which is single responsibility, right? So when you develop a function, it's just doing only one thing. And second is interface segregation, right? Your function is a single method interface. So 2 are out of the box, when you use functional programming. But the others also, delegation and dependency injection, all that stuff, slightly in different way, you can do it. But combinator is something a little bit specific. So if combinator is a combine multiple functions. So you basically chain. I would rather call it a chain. Chain multiple functions and then make your client code more functional, more reusable, flexible, I would say, and more fluent, as you will see in a minute. So I have here taken an interface called customer registration validator, which is a function which takes object of type customer and returns validation results, which could be valid or not, right? That's what it's going to be. But the bunch of stuff that needs to be done on the customer is quite a few, right? So customer, you need to validate its email, validate the phone number, validate date of birth, like that. So first one, so each one is a customer registration validator function. Each one is taking a customer and returning whether it is valid or not for email, valid or not for phone number, valid or not for the age, whether the person is greater than 16 or not. So you define these functions like this, 3 different functions, 3 different implementations of customer registration validator, and then you chain them. So what it means is you call them one by one in a sequence. So let's see how it is done. So now the trick is again one default method, right? So in that class, in that interface, you are allowed to define a default method. So here we defined a default method, which is returning again customer registration validator only, okay? And it is taking also customer registration validator. So what this helps in chaining. So now you have a customer registration validator, right? And you have an end method on it in which you pass the second validator. What it will do, it will chain both and give you third customer registration validator. So now you can chain another, validator. So you can keep going as many validators you have defined. You can chain them like this, and it is lazy. So it's not doing anything. You are just returning the implementation, right? And you're chaining the call so far. You're doing nothing. When things happen, when you call apply. So how does a client code look? Okay, client code looks like this. My first customer registration validator function is email valid. This I took it as a first. And then I call end on it, which is my default method. And I use it to chain. So I'm chaining the second one. Is phone number valid, right? With that, I'm chaining third one, is an adult, right? So once I'm done chaining this, which is left, till then nothing happens, and I say apply customer, at that time, it will go in a sequence, right? Does email validation, after done that, does phone validation after that, and then if it is valid, result is true. If not, somewhere in the middle, you are getting the result as invalid if it is not. Here is another example, which I don't know what pattern it is, but I have used it in the code. Is like, say for example, if you have a class which has one attribute, if you created a class which has an attribute which I need to transform. So here I have taken an attribute called root, which is a string. Basically, I want to showcase a string transformation. I have a string, I'm transforming. You can like do any kind of ETL transformation using this same pattern, that you have source data in ETL and you're transforming using transform functions, and then at the end you get back your transform value. So how it is done, right? So here what you need is that you have a class which wraps that particular data point that you want to transform, right? So that you somehow create the instance of that class by giving some initial value to it. So here I have provided an off static method, like a builder method kind of thing. And then you have to develop implement a method like this, where it will take the function, a method. I have named it transform here. So what it will do is it will take the function, it will apply that function on this root, like whatever the value we want to transform. After applying it, it will set its value the new value, right? So we have that value available, and it will return the class itself. It will return the transformer class itself. So it will apply the function and transform the class itself. This enables you to recursively call more transform functions on it. Okay. So how the client code looks when you do this, your client code looks like this: that you have a string transformer with the root hello. So you create a string transformer with the initial value hello, and now this is the one I want to transform, right? I want to do a bunch of stuff with it. So as in simple examples, I want to first convert hello to uppercase, and then I want to append Tom to it, and any other thing you can imagine, as long as it adheres to this interface. Remember, function has nothing to do with anything else except what it takes and what it returns. If you can somehow implement this portion, making sure that what it takes is a string and what it returns is a string, you can pretty much put anything here, and it will apply it. So you can like recursively call transforms. When you're done, you say, okay, I applied everything I need to. I get root obviously will give me the final value that I'm looking for. So that's all I had planned. I hope at least few people are new to functional programming. This is not really too much of a new thing. Java, it is here for a very long time, but it is very much possible because we are used to object-oriented method of developing. We don't really try, and it's also a little bit difficult. We don't really try using functional programming features of Java, but there are really some cool features. I do like using it, and I actually there are, and the streams and all this other stuff also is very useful when you are using streams if you are doing functional programming.
Yeah, that's right. Yeah, thank you, Nilesh.
No
I think Shyam has some questions. Shyam, would you like to ask your questions directly here? Shyam, are you there?
Is it in a chat?
Yeah, he also said something in the chat.
Oh, in the chat. Okay, let me.
I just thought you
I'm
might
trying
want
to get
to-
used to this.
Yeah. Can you see the chat? And he has his hands raised too.
Whether the input
That's
to
right.
the second function result
That's right.
from the so you can chain it like that. First function, but thing you have to have the same same function, right? So input and output types have to be same. Then you can chain like that, and your input will go to the and the magic is in that default method that it is implemented, right? And then if you go and look at the implementation of and then, it is first applying the first function, right? And it is returning that for applying the second function, right? So it's first whatever you pass into the end, that function is applied first, and then it applies the current function like that.
Shyam, did you get what the answer that you're expecting for? I guess I don't know if Shyam is still online right now. Okay, so maybe he's just up away or something. But okay, so anyone has any questions for Nilesh? Yeah. Maybe a question for you, Nilesh, is that under what circumstances would you not recommend using functional style programming? That
if you have a lot of so at the edge, right? At the edge, you don't do too much functional programming. So if you're like using messaging kind of event-driven application and where you might not consider using functional programming. At the REST endpoints level, you still have to develop. So you still have to develop some classes to handle the edge situations, right? Where you are making a REST call or you are listening to a message queue. When you are writing to a database, you still need certain classes and stuff. But
That's right.
So what you do is like you try to develop as much functions as possible. Another thing I have found is like develop static methods and static functions. So that automatically stops you from using instance variables and you keep the purity of your functions, right? So try not to use instance variable. But I have so far found that unless your logic is so complicated that it is difficult to implement in Java because we don't have a lot of functional program feature, you're easily able to put most of your logic in functions. It's just like how far you are ready to go. That's the problem with Java.
Yeah, sure. Yeah. Okay. Yeah. Thank you. Okay.
We'll stop sharing now and
Sure.
next caller.
Thank you. I guess Shyam, are you back or?
Yes, Nile. Yes. Sorry, ma'am. Hi, Nilesh. It was a very great session. I do have one question on function composition where you are combining two or more functions to create another function, right? So in that, the result of the first function is fed as the input to the next function. Is that how it works?
It's not the result. It's like they're executed in a chain, right? So you're like in combinator pattern. You have set of operations and you're doing it in a sequence. But none of the example that I have shown is where your output of the one is going as an input to the other. But I think there is a construct to do that.
Actually, if you go back to your page, function composition, where you are merging, that's where you showed that.
Yeah, let me share it again. Yeah. Okay, yeah. Was it currying advanced features, right? In a combinator pattern?
Further, like one more.
Here.
Not here.
Okay.
You still need to go up. Composition is called function composition. It is at the beginning of the session.
Oh, here. Okay.
Not even here, before. Yeah, here you go. So here you are adding the third line, you are adding add one, then multiple, right? So,
Right.
So basically, this example, right? Okay, here, right? Add one multiply two, apply three, right? So basically, for the first one, 3 is fed as the input, right? So the result of first add one is 4, right? It basically adds 3 plus 1.
3 plus 1, yes.
So then you are doing multi 2, right?
Yeah,
For
right.
that, the input is 4, right?
Yes.
That's what my question is.
Yes. Yeah. Yes.
Yeah. Then it returns 4 times 2 is 8. That's why you get this.
Correct.
Basically, if you look in depth, the result for the second one is nothing. Sorry, the input for the second one is the result of the first one, right?
Right. Yes, that's how you chain it. Yeah, but you have to make sure that it is integer to integer. You cannot combine two different kind of different kind of functions together. They have to be same type. As long as they are same type, you're able to do that.
The auto boxing won't work here. Java doesn't do the auto boxing.
Oh, that's.
Auto boxing.
Yeah, like automatically convert.
Yeah, that will. But yeah, right. So it will convert automatically, but you think is that function will have to be defined like this, right? In the generics, integer to integer, and that way.
I understood what you're trying to say.
Right.
Basically, if it is a string type, if you're trying to multiply, then it will fail.
Correct.
Thank you. Thank you so much. It was a great session. Thank you.
No problem.
Yeah, thank you. So, yeah. So any more questions for Nilesh? Anyone? Okay, so I guess we can still hang out too afterwards and ask questions if anyone will have any. So thank you, Nilesh. Thank you. Yeah, that's a very good, quick kind of overview, but also quite detailed too. So thank you, Nilesh. So now we will have Anna presenting writing bytecode the hard way, right? So yeah, so welcome, Anna. And Anna and I, we met because of Kirk from who came and presented for us too on the revolving door pattern. And Anna works with Kirk too at Microsoft. So welcome, Anna. So
yeah, thank you for having me. Should be sharing.
sure.
See. Yeah, here we go. Okay, perfect. So yeah, I work with, I don't know if you saw Kirk's talk, but I work with Kirk. I work at Microsoft and I work on the Microsoft's build of the JDK of Java. So I'm not necessarily a Java programmer or Java user in the in the more generic sense, but I do work with Java every day, just in a little bit of a different way. And I kind of explored that in my talk. So a little bit of a pivot, and it's also just kind of a fun, short talk. But maybe I'll go a little over 5 minutes. We'll see. So yeah, my presentation is building bytecode the hard way. Now you may be familiar with how to write bytecode the easy way, which is starting with a .java file and then using the Java-C compiler on that file to create your .class file, which is entirely written in bytecode. But how would we go about doing this the hard way? Well, you would take away the Java-C compiler and you would handwrite your .class file. And why would you want to do that, you might ask? Well, Java is founded on the principle write once, run anywhere, which the Java bytecode strongly supports. Java bytecode abstracts away any sort of hardware that you might be running on and simply just needs a JVM, a Java virtual machine, on that computer. So that's kind of the beauty of Java bytecode, and understanding that can help you further understand your Java programs. So how did I go about writing it the hard way? Well, I started with a tutorial. So yeah, I'm just going to take you through like a little demo of me writing Java bytecode, I guess, the hard way, writing that .class file. So I started with a Medium tutorial that took me through writing Hello World in Java bytecode. And I kind of embellished this to make it a little more interesting and fun. So as you can see, we have the .class file in this directory, and that's it. There's nothing else written, but you can run it just like the Java-C compiler created this class file. So you run it normally, and this is my program. So if you get a B, a bear prints out, and if you get an O, an owl prints out. So again, a little more fun than Hello World, and a little more aesthetically pleasing, if you will. So if you were to write this as a .java file, it would look something like this with 2 if statements. And if you get a B, print out a bear. You get an O, you print out an owl. But again, I just decided to do this the hard way, and I wrote it like this. So this is all in technically a .class file is in binary. I wrote it in hex to make my life slightly easier, and I added some spacing and some line breaks, again, for my own personal benefit, for formatting, so that I could understand where all my code was going and what was happening. And I broke this down even further for you guys to kind of see what all of this is doing. So as a whole, we're just providing information on the Hello World bytecode class. And yeah, we're just generic information. So you can see at the very top on line 1, we have the Java magic number, if you've ever heard, it's Cafe Babe. And the next 2 pieces of information are the major and minor version that this class file can run on. And then on line 3, we get the constant pool size, which is then followed by all the constant pool information, which is anything that stays constant throughout your program. So maybe it's the constant string. For me, it was that bear or owl. It can be the class names, method names. So, dot equals when you're comparing 2 strings. I had to do that in my program. And as you can see, it's a pretty simple program. That constant pool is already very large. So imagine the constant pool of a much more complex program. After that, we get into a little more information about the class. And on line 70, you can see that 1, and that number 1 references how many methods the class has, which for us, it's just 1. It's the main method. And we get into that main method information. And then within that, we have the actual instructions and code of that main method, which might be what you think of when you think of Java bytecode, if you ever think of Java bytecode. But technically, this whole file is Java bytecode. And that just includes like the if branches, pushing and popping to the stack. This whole thing relies entirely on a stack because, again, registers are machine specific, and Java bytecode, the whole idea is to abstract away from whatever machine you're running on so that it can run anywhere. So just showing you a little bit about like what it's like to code this way, I show a little example of changing just 1 byte. So this code that I just highlighted is the main method code, and that 2 represents the size of the stack. So if I make it a 3, obviously my program should still run. We just have extra stack, which isn't necessarily a problem in this program. But if we make it a 1, we actually do get a stack overflow. So you could see how coding this was a fun challenge, a little difficult. Debugging it was definitely difficult, but there were a few learning opportunities along the way. And just like a C programmer might learn assembly to better understand their program, a Java programmer can learn Java bytecode to better understand how your file that you write ends up getting to the end result. And it also teaches you that important principle of write once and run anywhere, and how that's actually implemented in Java. And that's the end for me. So a little quick. I can go into more detail if anyone has any questions.
Yeah. Let's see. Thank you, Anna. That's very nice. A nice little refreshing, different approaches of approach to doing that. That's very fun. I just have a question about the Cafe Babe, right? So do you know why? Then how that kind of came about? Yeah, the Cafe Babe.
No, I don't actually. I was on a talk with Kirk, like practicing this presentation, and he was like, well, I'll explain to you at some other time, but it's kind of a fun story. I don't know. Do you know, or are you asking me?
Oh, I'm asking you. I actually don't know about that too, but that's a very interesting thing. So that's why I thought, let me ask if you know about that. So, or does anybody know too about? I guess I can look that up too, but I'm kind of wondering. That's something new for me. So to get to know. So yeah, yeah.
No, yeah. Kirk said it's a funny story. I don't know what the story is. I mean, all files have a magic number at the top for you to and be able to tell what it is, but that Java just so happened to have a magic number that almost makes sense in English is a little funny, a little ironic. I don't know the story, but
yeah, that's right. Yeah, that's cute too. Like Cafe Babe is all number. So yeah, there's all hex. So yeah. Okay, yeah. So anyone have questions for Anna? Or?
So how do we? So once we get more understanding about bytecode, like how it will become useful to us in. So like I know like certain with the introduction of Lambda, there is invoke dynamic is something they have introduced, right? In later JVM. So does it help in kind of once you develop a program, are you able to go back to your bytecode and say, hey, did I develop something really efficient or I just messed it up? Like, it's something you can figure out looking at your bytecode that.
Yeah, I think there's a value in kind of understanding how you're writing your code, and if you're writing it efficiently in the way that like there's one way that the Java C compiler, compiles the bytecode better. I know there's also opportunities. There's like built-in libraries for you, kind of like in a C program, you can write in assembly directly into your program. There are some libraries where you can actually write in bytecode directly into your program too, which I would assume would have some performance benefits as well. So
that's true. Okay. Any more questions for Anna? Yeah. No? I guess. All right. So yeah, with that, the meetup, the main part, we come to a close. So thank you very much again to Nilesh and Anna for presenting. Those are very great presentations, and it's kind of nice, even though it's a small group, but I think it's a nice and cozy one. I really enjoy it tonight too. And thanks to Josh too for doing the MC and then doing also for the raffle. So thanks a lot.